For these next couple of problems, I'm going to be looking for the center of a circle, which is HK. I'm going to be looking for the x, y intercepts. The radius, there we go, and graph. So my first circle is going to be 2 times x minus 3 squared plus 2y squared is equal to 8. So the first thing I got to do is I got to divide out by 2 to get rid of all this front crap. So what I need to do is, well, first of all, let's talk about what we want to do. What we want to do is get this formula, this circle into the form of x minus h squared plus y minus k squared is equal to r squared. So we can tell what the center of the circle is, what the radius is, and it'll be much easier to graph from there. So like I said, we got to divide out to get rid of all this stuff in the front. So we divide everything by 2. That's going to leave us with x minus 3 squared plus y squared is equal to 4. And we already are in this form. This y squared is the same as y minus 0 squared. So this is the same as x minus 3 squared plus y minus 0 squared is equal to 4. So our center is going to be, so our center is equal to 3, 0. And we can find out our radius from here too. So we have 4 over on this side, and the radius is r squared. So we take the square root of 4. So the square root of 4, and that's equal to 2. So our radius is equal to 2. So now we need to find the xy intercepts. And for circles, they can have, depending the amount of intercepts a circle is going to have, it just depends on where it is. A circle can have 0 intercepts, it can have 1 intercept, it can have 2 intercepts, it can have 3 intercepts, or it can have 4 intercepts. Those are the only options available. So let's find out how many intercepts we have. And finding the intercepts for a circle works just like finding the intercepts of anything else. If we want to find the x-intercepts, we set y equal to 0. If we want to find, so let me write that out. So x-intercepts, y is equal to 0, y-intercepts, x is equal to 0. So let's find the x-intercepts first. So here's our equation. We can just use this one in this form. So we have x minus 3 squared plus y squared is equal to 4. So I'm going to find the x-intercept first by setting y equal to 0. So I'm going to have x minus 3 squared plus 0 squared is equal to 4. Now I'm going to FOIL this out. So I'm going to get x squared minus 6x plus 9 is equal to 4. I'm going to subtract 4 from both sides. X squared minus 6x plus 5 is equal to 0. Now I'm going to factor this. So I need two numbers that multiply to be 5 and then add to be negative 6. So two numbers would do that would be minus 1 and 5. Minus 1 times minus 5 is positive 5, and then minus 1 plus minus 5 is minus 6. So I have x minus 5 times x minus 1 is equal to 0. So my solutions are going to be x is equal to 5 and x is equal to 1. So these are going to be my x-intercepts. So my x-intercepts are 1, 0, and 5, 0. So now that we have the x-intercepts, let's do the y-intercepts. So let's rewrite our equation here. X minus 3 squared plus y squared is equal to 4. So now we're going to have x equals 0 to find the y-intercept. So we're going to get 0 minus 3 squared plus y squared is equal to 4, which is going to give us 9 plus y squared is equal to 4. We subtract 9 from both sides. I'm going to get y squared is equal to negative 5. And now in order to solve this, I need to take the square root of both sides. I'm going to get y is equal to the square root of minus 5, which is not a real answer. We can't take the square root of a negative number. This is saying, basically what this is asking is, what two numbers multiplied together equal negative 5? There's none, because minus 5 squared, or the square root of because there's no square root of minus 5. So you can't take the square root of a negative number. So there are no solutions. So whenever you get a non-real answer like this, that means there's no intercepts. So we have no y-intercepts. So no y-intercepts. And when we graph it, we'll see that as well. So now let's graph our circle. And I generally always use, I can't think of any reason why someone would use the intercepts to graph. And in some cases, there would be no intercepts anyways to graph. So this is one of those where you just want to use the radius to graph. It's the easiest. We had a center of 3, 0, if I remember correctly. We had a radius of 3 as well, or a radius of 2. So we had a center of 3, 0, and a radius of 2. So let's go over to 3, 0, and that's right here. And we have a radius of 2. So I'm going to go over 2 in this direction, put a point there. I'm going to go up 2, put a point there. I'm going to go to the left 2, put a point there, and I'm going to go down 2. This is all from the center. And put a point there. Now I'm going to use this circle thing so I can cheat and not have to draw. Have an embarrassing failure of a drawing. Yeah, well, there we go. So that's what our circle looks like. And here we have our, remember our center is 3, 0, and our radius is equal to 2. And see how it does not intersect the y-axis at all. And remember, we found our x-intercepts, which are 1 and 5. We go over, this is 3, 1, 2, that's 1, 1, 0. And we go over 2, from 3, 0, 1, 2, that's 5, 0. So our intercepts are correct. Now let's do one more. And this one is going to be significantly trickier. So it's going to involve a lot of completing the squares. So let me write it out. It is x squared plus y squared plus 4x minus 4y is equal to, actually, minus 1 is equal to 0. So the first thing we need to do again is get it into this form, x minus h squared plus y minus k squared is equal to 0. So we need to get it into this form. So the first thing to do is to get all of our like terms together. So let's put x squared plus 4x plus y squared minus 4y. And let's just subtract this 1 over to the other side. Oh, this is not 0. This is r squared. Yeah, I don't know why I put 0 there. Must have been thinking ahead. Alright, so we have everything, all of our like terms together, but we still can't just factor it like we did the other one. So what we're going to need to do is complete the square. So for this term, x squared plus 4x, I can complete the square by adding 4. Let me do that in a different color. Adding 4 plus y squared minus 4y. And for the y's, I can also complete the square by adding 4. It just happens that these are equal. But it's a circle, so they would be equal. Well, I guess we don't know about ellipses yet, or any of that other stuff. Is equal to 1. And what I add on this side, I must add to the other side. So plus 4 and plus 4. Remember, I can do whatever I feel like to an equation. I can divide this side by 1,000. I can add 1,000,000,000 to it. But whatever I do to this side, if I add 1,000, I got to add 1,000 to this side. If I divide it by 1,000,000,000, I got to divide this side by 1,000,000,000. So let's get our new equations. Let me do a different color, I guess. So if we complete the square here, we can now factor it. So this becomes x plus 2 squared plus, and if we can now factor this, and this is going to be y minus 2 squared. These are perfect squares, which is equal to 1 plus 4 plus 4, which is 8. So now we have it in our standard form of a circle. So we can now find the center, which is going to be minus 2, 2. Oh, wow, that was really terrible. I forgot the 1. 4 plus 4, that's the only thing when you do different colors. You tend to... I hope no one... If people don't like me doing the different colors too often, let me know, because sometimes, like the mistake I just made, I just added the 4s and I just completely forgot about this 1. So we have 9 over here. 4 plus 4 plus 1 is 9. So our radius is going to be 9. R squared. So the square root of 9 is 3. So our radius is equal to 3. So there's 2 bits of information. Here's the center, here's the radius. Now we're going to go and find the x-intercepts and the y-intercepts. And this is going to be the part that's going to get a little bit tricky. So let me pick a different color. Alright. So let's find the x-intercepts first. So if we're going to find the x-intercepts, the y is going to be equal to 0. So we get x plus 2 squared plus 0 minus 2 squared is equal to 9. That's going to give us, I'm going to FOIL this out, that's x squared plus 4x plus 4. Essentially we're just multiplying this back out again, so we get the same thing. And we're going to have minus 2 squared, so that's also 4, which is equal to 9. So now what I'm going to do is I'm going to subtract 9 over to this side. 4 plus 4 is 8, so we're going to get a minus 1. So x squared plus 4x minus 1 is equal to 0. And this is a part where a lot of people are going to have trouble, because they're going to get to this part and they're going to say, well, now I need to factor this in order to figure out what numbers multiplied equal 0. But the only thing is, we have to find two numbers that multiply to be negative 1. So we need, let me do this in a different color. So we need two numbers, a times b, that equal negative 1, and then a plus b need to equal 4. But what two numbers are going to multiply to be minus 1? At least two simple numbers. Obviously there are two out there, but there are not going to be easy numbers. Or not even have to be numbers, just values. Two values that multiply to b minus 1. I mean, the only factors of 1 are 1 and minus 1. And neither of them is going to be able to add up to 4. So we're in trouble. But this is where you have to know to complete the square. So we can use our old friend completing the square. So I'm going to, actually I don't need to scroll down yet. So I'm going to have x squared plus 4x minus 1, and then I'm going to complete the square. In order to complete the square, I need to get a 4, so I'm going to add 5. Now, hopefully I don't mess up by overlooking the number that's in purple. So we add 5 to this side as well. So this is going to give us x squared plus 4x plus 4 is equal to 5. Now I can factor this. So I get x plus 2 squared is equal to 5. And now, in order to solve this, I have to take the square root of both sides, because this is not equal to 0. If it was equal to 0, then we can say, oh, well, we can say x minus 2 is the only answer. But this is not equal to 0. This is equal to 5. So we got to take the square root of both sides. So we get x plus 2. And now here's another part where a lot of people are going to mess up. So when we take the square root of a number, of anything, it's going to equal the positive and negative values. So we're going to get plus minus the square root of 5. Because, again, since we've taken this, there are two different numbers. So when we take the square root of 5, there are two different numbers squared that can give us 5. Obviously, there's the so if we, let me write it over here in a different color. So there are two numbers that can give us 5. Two numbers. So we can have square root of 5 squared, and that's going to give us 5. But we can also have the negative square root of 5. And notice that this negative is not underneath the radical, so it's okay. We can have a negative square root of 5. We can have the square root of negative 5. And that's also going to give us 5. So you have to know that we're going to get a positive and a minus value. So that's a place where a lot of people are going to mess up. And then we subtract this 2 over. So x is equal to negative 2 plus or minus the square root of 5. So these are going to be our 2. And notice there are 2 because we can have plus the square root of 5 or minus the square root of 5. So these are going to give us our 2 x-intercepts. Well, let me write them out. So our 2 x-intercepts are going to be minus 2 minus the square root of 5, 0, and also minus 2 plus the square root of 5, and 0. So these are our 2 points. So now let's do the y. And in fact, if we're pretty good at math, what we're going to be able to do is spot that it's going to be, instead of a plus 2, instead of a minus 2, it's going to be a plus 2, because the numbers are all the same except it's minus 2 instead of plus 2. But in case you're not familiar enough or not experienced enough to see that, let's just solve it anyways. So we had, let me rewrite the formula. Let me do a different color. So we had x plus 2 squared plus y minus 2 squared is equal to 9. And we're going to look for the y-intercept this time, so we need to make x equal to 0. So 0 plus 2 squared plus, and I'm going to FOIL this out, and this is going to give us y squared minus 4x plus 4 is equal to 9. Oops, I don't need that. So we have 4, so that's going to give us y squared minus, oh, I put x here. I'm sorry, that's a y. minus 4y plus 8 is equal to 9. I'll subtract 9 over. So this is going to look very familiar. It's almost exactly the same. So y squared minus 4y minus 1 is equal to 0. So again, we need to complete the square. So y squared minus 4y minus 1. And I'll do it in different color again, just to make sure everyone knows that I'm completing the square. So plus 5 is needed to complete the square. Is equal to 0 and plus 5 again. So we're going to get y squared minus 4y plus 4 is equal to 5. So again, this looks very familiar. The only difference is that this is a minus 4. So if we want to factor this, this is going to be y minus 2 squared is equal to 5. And again, we're going to take the square root. So y minus 2 is equal to plus or minus the square root of 5. So our y-intercepts are going to be 2 plus or minus the square root of 5. And if we want to write them out as points, it's 0 minus, or no, that was the x. The x was the minus. 0 plus positive 2 minus the square root of 5, and 0, 2 plus square root of 5. So these are the y-intercepts. So those were a little bit tedious to get, and unless you know about completing the square, you're not going to be able to find them. Unless you already know the quadratic formula, which we haven't gone over yet, but a lot of people remember that from Algebra 2. You can use the quadratic formula. In fact, whenever I see that I'm not going to get a whole number, I don't really bother with all of the completing the square stuff. I just use the quadratic formula. So if you know the quadratic formula, use that if you want, but if you don't remember it, you need to complete the square. And if you don't like completing the square, try to learn how to use it, because it is very useful. It's very, very useful whenever you find a situation to use it. Actually, later on in calculus, it's going to be essential, like in calculus 2, to be able to complete the square. But for a while, it's not going to be that important in this class. So don't feel too panicked if you don't really get it. That's one of those things that takes some people a little while to get. So our center was minus 2, 2, and our radius was 3. So we go minus 2. Oh, I didn't want to put a point there. So minus 2, 2. This is where I wanted to put a point. And we had a radius of 3. So I'm going to go 1, 2, 3. So that's a point on my circle. I'm going to go up 3, 1, 2, 3. That's a point on my circle. Go over to the left, 1, 2, 3. That's a point on my circle. And I'm going to go down 1, 2, 3. And that is also a point on my circle. Now I just need to borrow my circle tool, so my graphs aren't too embarrassing. And that one actually almost looks like a circle. I can't believe it. Wow, that's amazing.